Let's wait for 1 minute so that other can join. Alright, so let's start. Can you see this board?
Yes, sir.
Yes, sir.
Okay, good. So in the last class we discussed Miller indices, right? Any doubt with the concept of Miller indices? Miller indices से लेकर कोई doubt है आपको?
Sir.
Yes.
Sir, if the third coordinate is 0 while finding the planes, then we have to make the other two, only the other two coordinates to integer, no, sir? Smallest integer, keeping third to be 0.
Right. So so situation is something like this. Let us say, let me plot it 2D lattice. Okay. And now a plane will be given by a line only. A plane की जगह मैं सिर्फ एक line draw करूँगा. And instead of 3 indices, I will have only 2. 3 की जगह 2 indices होंगी. The question here is, what are the Miller indices of these planes? इन planes का Miller indices क्या है? So there can be many planes parallel to this. This is one plane. I can have n numbers of plane like this. Okay, something like this. So the question is, where do we put, I mean, from where we start measuring? I mean, from which point I should measure the intersection along the axis? So let me assume that this is x-axis. मान लेते हैं ये x-axis की direction है, ये y-axis की direction है. But where is the origin? Origin कहाँ है? So if we are, let us say, focusing at the intersection of this plane A, यदि हम A के intercepts पता करना चाह रहे हैं x और y के along, then my origin should not be at A. मेरा origin A पर नहीं होना चाहिए. It can be anywhere else. बाकी कहीं भी रख सकते हैं, A पर ना रखें. Because if you put origin on A itself, then intersections are 0, right? So you can choose any other point as origin. You can choose this, which is quite easy to deal with. We have one here, distance equal to 1 unit, 1 unit cell, distance is equal to 2 unit cell. You can choose this point also. Obviously the distance is somewhat different. It is like half of unit cell. This is 1 of unit cell. You can choose this point also. But your point, your origin cannot be on the plane. आपका origin plane पर नहीं हो सकता, right? Because in that case the interception has no meaning. In this case you have negative points. अब आपके पास negative point है. This distance is equal to -2 units. This distance is equal to minus, sorry, how much? So here this plane, right? Minus whatever 4 unit or so. Okay. But HKL will always be same. Miller indices किसी भी case में same ही आएगा. So once we know the Miller indices, one main thing that we all are interested in, and it has many applications. Interplanetary spacings.
Sir?
Yes?
One more doubt is there.
Yes.
Sir, 1 minute. Sir, 111 gives you a triangular plane from Miller indices to plane. I'm talking about that. 111 gives you a triangle.
So plane has infinite area. Plane actually has infinite area. So what is 111 plane? 111 plane is this. So let me draw some. These are the coordinate system. These are some supporting lines. I mean, we have a grid like this. Okay? It's a time-taking thing, but anyway. So we have lattice point where we have lattice point here. We have here. All these points are lattice point. Not only this, we have lattice point here also. So it's a very complicated diagram now. I mean, just imagine a cube. एक cube को imagine कीजिए, and we have lattice point at all the intersections. हर एक intersection पर एक lattice point है. What is 111 plane? 111 plane क्या होगा? These are the Miller indices. Intercepts on axis are inverse of them. Inverse of them means 1 upon 1, 1 upon 1, 1 upon 1, multiply with the size of unit cell along the axis. Let us say we have simple cubic lattice. Then what is the size, what is the length of unit cell along x-axis? A. So A into 1. Along y-axis, it has same length, A upon 1, A upon 1. So 111 plane intercept or cut the xyz axis at a distance of a from A origin. Means if these are the axis from a lattice point, यदि किसी lattice point से axis जा रही है, so we have one lattice point here, एक lattice point तो यहाँ पर ही है. The 111 plane is like this. It is cutting x-axis at a distance of A. It is cutting y-axis at a distance of A. It is cutting z-axis at a distance of A. So the plane is like this. But it does not mean it is triangular shape. इसका मतलब ये नहीं triangular shape है. It is in the infinite directions. ये infinite dimension में है. Sorry, it has infinite area. It is extended in all directions. In first quadrant, we have only a triangular piece of that plane. Okay.
Sir?
Yes.
Sir, if someone puts a bar over each one, then what does it mean, sir? Like 1 bar, 1 bar, 1 bar.
So bar means negative. So you can ask, what is one var one plane? It means the intercepts on axis are a upon 1. A upon 1 var means minus a upon 1. So what are the intercepts on axis? A minus a. What is this plane? ये कैसा plane है? Something like this. So it is cutting x-axis in positive side. It is cutting y-axis on negative side, and it is cutting z-axis on positive side. So we have intercept A on x-axis. It has intercept minus A on y-axis, maybe here. And it has intercept A on z-axis, like here. What kind of plane is this? So again, it is not a triangular plane. It is infinite plane. In the lower quadrant, it look like a triangle. Okay. What about Banvar plane? Is it same as 111? क्या ये 111 जैसा ही है? So this plane Banvar is cutting all the axis on the negative side. What does it mean? क्या मतलब हुआ इसका? Let me work in 2D system. So 1 plane means this line. Intercept 1 intercept A on both axes. This line is 1 line. Okay. What about one var line? Intercept minus A on x-axis, intercept minus A on y-axis. What kind of line is this? Minus A means here. Minus A means here. So you can see these two are parallel lines. Okay. So when all the indices are negative, they are equivalent to all the indices are positive. Or in other words, one var line is equivalent to one var one line. What is one var line? This. Intercept on x-axis plus A, intercept on y-axis is minus A, this line. What is one var one line? Intercept on x-axis is minus, intercept on y-axis is plus, this line. Both are parallel, so both are equivalent. Okay. So one var plane is equivalent to one plane. All right. I mean, you can always put an extra minus sign. So what is interplanetary spacing? Interplanetary spacing means, let us say I have a lattice like this. So I am going to draw only a 2D lattice. So I have only H and K indices. I do not have L. आप मान सकते हैं कि मेरे पास सिर्फ H और K indices है, L indices नहीं है. Okay, this is the plane. And let us say this is the lattice, this is the plane. Okay. So this is x-axis, this is y-axis, z-axis is perpendicular to this plane, and this line represents a plane parallel to z-axis. I mean, if you see a plane from the z-axis, it will look like a line only. यदि कोई plane z-axis में है, this is x, this is y, this is z. यदि plane z-axis के ऊपर ही होगा, then it look like a plane line only. What are the Miller indices of this plane? इसकी क्या Miller indices है? So A naught is, let us say, this gap, this is the, what is unit cell here? This is a unit cell, right? So unit cell has size A along x-axis, it has size A along y-axis. Let us say it has same size along z-axis also. What are the intercepts? Along x, how much is the intercept? A divided by the unit cell. So along x-axis we have an intercept of 1 unit. What is the intercept along y-axis? So we can see 1, 2, 3. Total length is 3a, size is a naught, is equal to 3. It is 3 units away from this origin. What is the intercepts on z-axis? The plane is parallel to z-axis, so it is cutting at infinity on z-axis, right? What are the Miller indices? Now next step is invert these numbers. Next step is convert them into the nearest set of integer. What is the nearest set of integer? 3, 1, 0. So this is a 3, 1, 0 plane. This line represents 3, 1, 0 plane. Okay. I will have many such planes. ऐसे बहुत सारे plane होंगे. This is one of the plane only. ये सिर्फ एक plane है उनमें से. Next question is, what is the gap between such planes? ऐसे planes के बीच कितना gap होगा? Let me remove the unnecessary lines. So this is one plane. Can you please tell me what is the nearest plane to this plane? इसी के parallel जो next plane होगा वो कौन सा होगा? Which point will it pass through? Let me first name the point. A1, A2, A3, A4, B1, B2, B3, B4, C1, C2, C3, C4, D1, D2, D3. Next plane, which is nearest to this plane, will pass from which point? वो किस point से pass होगा?
B2.
Right? If I draw another plane parallel to this, then it will pass through. You can check. It is passing through B2, right? What we are interested here is this separation. How much is this separation? Or
Sir,
we can, yes?
Sir, I didn't understand this line, sir. How exactly is this line or plane?
Okay. So, see, this 310 plane, obviously it will pass through some point, right? So I have one plane which is passing through some of the point of the lattice. Now I want to know next 310 plane passing through any of the point. Nearest to this plane A, this is plane P1. P1 is a 310 plane passing through some lattice point. It may have only one point. It may have more than one point also, that we do not know. Now I am trying to find P2. P2 is also 310 plane. Okay. It should pass through some point. Okay. And it is nearest to P1. So right now we are just looking into this geometrical figure. If my P1 is passing through the point A2 and D1, then according to your common sense, which plane should behave like P2? वो कौन सा plane होगा जो P2 की तरीके से behave करेगा? I mean, it must have the similar indices. Similar indices means it must be parallel to P1. It must be nearest to P1 also, and it should also pass through some point. वो किसी ना किसी point से pass होना जरूरी है. Okay? And we have lattice point here also. Although I did not draw all the points, we have lattice point everywhere. We have lattice point here also. Lattice points are there in infinite universe. Okay? There is no end to the lattice point. I am just drawing 16 of them, but they are infinite. Infinite. Okay. So the question is, which plane is parallel to P1 and it is passing through any one of the point? Or I can say in this way also. Let me draw one more plane. Let me draw this plane. Plane P3. P3 means this. This is P2. P3 will not pass through any of the point in the lattice. You can check, you can prove also, although proof is quite difficult, but you can check it very easily that P3 plane, although it has similar indices, but it is not going to pass through any lattice point in this set of infinite point. इस पूरे infinite points के set में P3 किसी भी point से होके नहीं जाएगा. It is the P2 which is the nearest plane which will pass through at least one of the point of the lattice. Okay. Now the next task is to find what is the gap between P1 and P2.
Sir,
Yes.
why the P3 will not pass through any point?
Okay, so I'll give you answer. Just give me some time. Can you find the distance between P1 and P2? All you know that P1 is a 310 plane. और सिर्फ आपको सिर्फ इतना पता है कि P1 310 plane है. So I want to know how much is this horizontal gap. ये horizontal gap कितना है? Between A2 and the next. Although यहाँ पे कोई lattice point तो नहीं है. How much is this gap?
Sir, we know that perpendicular direction, so yeah, we can find.
This is, don't be in hurry. Let me tell you what is the answer here. You know the answer. This is equal to A by H. How much is this vertical distance? ये डिस्टेंस कितना है? The vertical separation between these two planes. This is equal to b upon k. Do you know why? Let me give you some hint, although it is a kind of mathematical thing, but still let me try to give you some hint regarding this. Let me remove the unnecessary lines.
Sir, a plane can also pass through C1, no, sir?
Yes, that is also nearest. Okay. So first let me focus on the right hand side, because left hand side and right hand side are equivalent. Yes. So B2 and C1 are somewhat equivalent here. So we have P1 which has integer cut on both axes. If we take A1 as origin, यदि A1 को origin माने, so P1 पहला plane है, P1 is the first plane which has integer cut on both the axes, right? Along x-axis it has a cut at 1 unit cell. Along y-axis it has a cut at 3 unit cell. What is the next plane which will have integer cut? Next plane क्या होगा जो integer cut show करेगा? That will pass through, I think, A3 and
D2.
not D2. AB, it is much above this, right? Let me draw that plane. So we have one cut here. So next plane is something like this. I did not draw that many lattice point.
Sir, E1, sir.
Let us see. So this is the next plane. Na? Where does it cut?
Sir, 6, 8, not
8
distance.
point. Sir, 8 above.
This document is not working properly today. Let me show you. Let me remove the extra part here. So we have points here also. So this is D1. Then we have D2 here. Sorry, D1. This is E1 here. Okay. Then we have F1 here. And then we have G1 here. This point will pass through G1. How much away it is from A1? A1 से कितना दूर है? At a distance of, it is 9 times A. Right? Next question is, how many planes will be there between P1 and, let me call it, P3?
Sir, it is 6 times A.
Okay, 6 times A, right? It is 6 times A, right? Now the next question is, how many planes do you expect between P1 and P3? P1 और P3 के बीच कितने planes होंगे?
2.
Think very carefully about it. And in fact, this answer is equivalent to this. When you invert these numbers, what was the inversion? 1 by 1, 1 by 3, and 0. You multiply it with which number? 3 to make them integer, right? Between P1 and P3, there will be 3 planes. I mean, including P3, there are 3 planes. So one is P2, second one is P4. जो अगला plane होगा वो P4 होगा. Okay. So we have this plane, this one. So between two planes which pass through integer points, matlab we pass through integer distances, we have number of planes equal to the LCM of these numbers, equal to the least common multiplier of all these numbers. So this is a kind of mathematical thing. If you think peacefully and carefully, you will agree with all these kind of concepts. Okay. That is why I am saying that this distance has to be equal to AYH. ये distance AYH होगी, and this distance is equal to, this vertical distance is equal to B upon K. Okay. The next distance will be equal to how much? 2AYH, then 3AYH. Okay. And 3AYH has to be integer. वो integer क्यों होगा? Because your least common multiplier is 3. Same is here. First distance is BYK, second distance is 2BYK, third distance 3BYK. And what is 3BYK? 3BYK has to be integer. क्यों integer है? Because 3 is the least common multiplier. You get these numbers integer by multiplying by 3. So this 3 factor is everywhere in this lattice. How many planes will you have between two planes which have integer intersections? 3. यदि आपका LCM 4 होता, आपको 4 प्लेन मिलते हैं यहाँ पर, right? So we have this kind of scenario. One plane is passing through this lattice point. Yes.
Sir, this B by K in this case would be A now.
Yes, it is equal. It is equal to A by K, right? So since 3B by K is equivalent to A by K, because all A, B, C are same here. But if we have a non-cubic unit cell, if a unit cell has different length in different directions, then obviously A, B, C are different. So we have a situation like this now.
Sir,
Yes.
yes. Here ABC are unit cell edges, right?
Yes, these are the length of edges of unit cell. So we have a cubic unit cell, all the edges are same. You can do the same thing for non-cubic unit cell also. So if one plane is passing through this point and it has indices HKL, then the next plane nearest to this will have intersection A upon H along x-axis, B upon K along y-axis, and C upon L along the z-axis. So we have this plane parallel to this, and this distance is A by H. ये distance A by H है. This distance is B by K. Task is to calculate minimum distance, I mean the perpendicular distance between these two planes. Okay. So how do I find such a distance? Now it's in mathematics. ये पूरा math है. So what is the equation of such plane? Do you know the equation which has intercept some PQR on XYZ axis? If we have a plane which cut x-axis at a distance P, at a distance Q.
Sir,
X by P plus Q by
Y by Q plus Z by R is equal to 1.
equals to 1.
So it is the extension of line. We have this equation for that plane. So what is the distance here? So the HKL plane is at this much distance. So the equation of the plane is x upon A upon H, means plus y upon B upon K plus Z upon C upon L, okay, is equal to 1. So I know the equation of this plane. Now the task is to calculate its distance from the origin. ये origin से कितना दूर है? How will I calculate this distance? Any suggestion?
Sir, using distance formula.
But first I need to know the point from where I want to calculate distance. क्या वो point ये है, वो point ये है,
Sir,
or it is that point? Yes.
sir, we can calculate the angle between this AY line and the plane, and then using trigonometry we can calculate this.
So when I say minimum distance, what is the property? This particular line is going to make 90-degree angle with the plane. जो भी particular line है वो plane से 90 degree बनाएगी. Then we have the shortest distance. Obviously, any other line is not going to make a 90-degree angle. So how do I find that line? वो line कैसे पता करी जाए? So do you have any idea how to do all these kind of things? Do it in two dimension only. पहले 2 dimension में करके देख लीजिए. Because their life is quite easy. We have only x and y axis, and we have this line. Okay. It is cutting x-axis at a distance a, it is cutting y-axis at a distance b. So the equation of line is this. I am going to find distance of this line from this point, which is origin here,
Sir,
d. How do I calculate d? Or how do I find this point p? मैं इस point को कैसे पता करूं? Yes?
sir, those both green lines, we know the intercepts, no, sir?
Right, we know the intercept. So
Sir, then we can put them into plane equation, and we have this formula, no, sir? ax1 plus by1 plus c z1 plus d by under root a square plus b square plus c square.
okay, so you know the formula. My question is, how do you get that formula?
Okay, sir.
Right? Do you know the equation of this vector, which is perpendicular to this line? I mean, let us say this vector is alpha I cap plus beta j cap. What are alpha and beta here? Any idea of alpha and beta? Or what is
Sir,
the equation
intercept
of? Yes?
OA is alpha, sir.
I didn't get you.
Sir, OA length is alpha, sir, and OB is beta, sir.
No. Okay, so first of all, let me use the correct wording. This is point A, this is point B. This length is A, this length is B. Okay. And question here is OP is equal to how much? Okay. And instead of finding this question, इस question को ढूंढने की बजाय हम कुछ और ढूंढने लगे हैं. I have this vector which is perpendicular to plane, or actually OP is parallel to alpha I cap plus beta j cap. Question here is, what is alpha beta? Alpha beta क्या हो सकती है?
Sir, alpha is A and beta is minus B.
I think right. So what is vector AB? AB vector कैसे लिखेंगे आप? Can I say vector AB is like, so vector AB is this vector, right? It has minus A distance along I axis and it has plus B distance along J axis. Now this vector OP is perpendicular to AB, right? OP is perpendicular to AB. इसका क्या मतलब हुआ? Alpha I cap plus beta j cap dot minus A I cap plus B j cap has to be equal to 0. This simply means that if alpha is equal to A, beta has to be equal to, alpha is equal to B and beta is equal to minus A, right? Now you can check. So what is this vector now? B I cap plus A. B I cap plus A j cap. Okay. So this is OP. Take a dot product with AB and you get 0. Right? So we have got OP. What is the unit vector along OP? OP के along unit vector क्या होगा? So OP unit vector B I cap plus A j cap divided by its length. Okay. What is this? What is this actual vector OP? OP की actual length कितनी है? D. Right. So I can say this OP vector is equal to D times unit vector along this. कितना हुआ ये? D upon square root A square plus B square B I cap plus A j cap. So I know this vector exactly now. So what are the coordinate of point P? P के coordinate क्या है? Can you tell me? So point P is nothing but D upon square root A square plus B square into B. D upon square root A square plus B square into A. These are the coordinate of P. Okay. These points lie on this axis. ये जो point P है ये लाइन पर लाई करता है. It means for these points this equation is true. So if I put x is equal to this value, if I put y is equal to this value, this point must satisfy this equation. Put it d b upon a plus d a upon b is equal to 1. What we are interested in? D. हमें क्या चाहिए? D. D is out. Square root a square plus b square on this side. What we are left here is b upon a plus a upon b. How much is that? A square plus b square upon ab. So we have a square plus b square upon ab is equal to square root a square plus b square. Or what is d now? ab divided by square root a square plus b square, or it is also equal to 1 upon a square plus 1 upon b square. This is a formula that you know, right? ये formula आपने पढ़ा होगा. Okay. There are many methods. This is one of the method. You may find it somewhat lengthy. आपको थोड़ा lengthy भी लग रहा होगा. You can apply your own technique also. आप अपने से भी formula बना सकते हैं. So this is a distance of point O from the plane. In our case, what is A? हमारे केस में A किसके equivalent था? A is equivalent to A upon H. B is equivalent to B upon K. C is equivalent to C upon L. So what is the interplanetary spacing? D is equal to 1 upon square root. 1 upon A means H square upon A square. K square upon B square plus L square upon C square. Or for simple cubic, because most of the crystals have simple cubic lattice, all the edges are same, and formula is becomes h easy as a upon square root h square plus k square plus L square. So you ultimately get this formula. आप अपने से भी ट्राई कर सकते हैं, आपको फाइनली ये फॉर्मूला मिलना चाहिए. If you do not get this formula, then let me know. Okay. So you can follow this calculation. You can make your own calculations. There are many methods to solve this problem. Those who have studied 3D geometry, they directly remember this formula. जिन्होंने मैथ पढ़ा है 3D geometry का, उनको ये फॉर्मूला सीधे सीधे याद है. So this is the interplanetary spacing. Why do we want to study it? इसको स्टडी करने, इसको पढ़ने से क्या फायदा होगा? We have many applications of this D. This has lots of information about the system. ये नंबर में बहुत सारा information. What kind of information? Let me give you some hint.
Sir, can it be taken as the slit width, sir? In the diffraction part, we stopped now.
Yes. Is it slit width? Actually, no. Why? So I'm going to cover the diffraction part now. So I'll answer your question in between. So what is X-ray diffraction here? First of all, how do we carry out diffraction? What is the methodology? What kind of setup we have to perform X-ray diffraction? So X-ray diffractometry has this kind of setup. We need one X-ray source. Okay. So we have this Polish tube. We have some metallic plate which is made of heavy atoms, and we emit some high energy electron beam on this X-ray, on this plate, and that's how we generate X-ray beams, right? Now these X-ray beams will fall on a sample whose X-ray diffraction we want to see. ये X-ray beam किसी एक sample पर fall करेंगी. Let us say this is the sample. Depending on the thickness of the sample, we may have some X-ray transmitted, we may have some X-ray reflected. We usually have quite thick sample. I mean, the transmittance is extremely low. So in the case of X-ray diffractometry, we observe the diffraction pattern in the reflected side. जैसे कि ऑप्टिक्स में देखा होगा, हमें diffraction pattern transmitted side में देखते हैं. Here we will see the diffraction pattern in the reflected side. Okay. This is the transmitted side. Now, how do we observe this reflection pattern? Because these are X-ray, we cannot look them directly. इनको directly नहीं देखा जा सकता. So the setup consists of something like this pattern. This sample is placed on a round table. इस sample एक round table पे place किया जाता है. So means you can rotate this sample as per your choice. इस sample को आप rotate कर सकते हैं in any angle. The angles can be first of all, this sample can be rotated, and we can read the rotation on this table. Table पे से हम rotation read भी कर सकते हैं. Obviously, this X-ray, after reflecting through this sample, will it will go in any direction. It can go in this direction, it can go in this direction also. How do we read this X-ray? Obviously, we have to apply a detector. Do you know how does a detector work? पता है आपको detector कैसे काम करता है? Most of the detectors have the same principle. Put a gas inside the detector, a gas which can be ionized by incoming X-ray. Okay. So, and you put some electric field inside the detector by applying some battery. So depending on the strength of X-ray, more and more gas or little amount of gas will get ionized. X-ray की strength के according इसमें gas ionized होगा. Depending on the ion produced because of X-ray, we will get some current. And by looking at this current, we can get some idea of the strength of the X-ray. इस current से पता कर सकते हैं कि X-ray का strength क्या था. Okay. So we have a detector, and this detector can rotate throughout. Okay. So this detector can rotate around the sample. So that's how we look at the diffraction pattern. Now, what kind of diffraction do we observe? Let us see the condition of diffraction now. So we have a setup like this. We have a sample. Sample means we have a lattice. So let me draw some lattice first. Okay. In this lattice, we can have many type of planes. For instance, we have planes like this, horizontal. These are like 100 plane. We can have these kind of plane, 010 plane. Or we can have 001 plane also. We can have this sort of plane, 111 plane. We can have 1 - 1 plane. Okay. So there are many possible planes here. The X-ray is coming from this side. Okay. Obviously, it will fall on some lattice point. Some of the X-ray will transmit it, some of them will fall on lattice point, and they will get reflected in any possible direction. ये कहीं भी reflect कर सकती है. So X-ray are coming from here, and they are making angle with the surface of the lattice theta. This is not angle of incidence. Angle of incidence is which make angle from the perpendicular of the plane. This is angle of incidence. This is not angle of incidence. What is the name of it? This is called glancing angle of incidence. So if you know any one, you can find out other. The summation of these two angles is always 90 degree. Where do we have detector? We put the detector at the same glancing angle. Means this angle is also theta. ये angle भी theta ही रखा जाता है. It simply means we are looking at the intensity in the reflected side. हम उस intensity को देखना चाह रहे हैं जो reflected side में मिल रही है. So we have many X-ray. This is the path of one X-ray. We can draw as many. We can draw other X-ray also. Like we have this X-ray as well.
Sir,
Yes.
sir, for keeping the detector in the glancing angle, first we have to know the normal, no, sir.
So since we know the surface of the crystal, we know the normal also, right? Because this surface is flat. Whatever is the sample we are using, it has a flat surface, right?
Okay, sir.
You may ask, how do we make sure that the planes of lattice are in this arrangement? हो सकता है आपने तो surface flat कर दी. The lattice planes are in this arrangement.
Yes, sir.
Inside
This is what I wanted to ask.
So yes, we have an answer to this also. Okay. So right now these two angles are with the surface that we see from eye. These angles are with respect to the surface which we polished, जिसको हमने घिस के सही किया है. Okay. We do not know what is the orientation of lattice point inside. अंदर के lattice point का क्या orientation है वो हमको नहीं मालूम. So we have many X-rays here. They all are in phase when they incident, but they reflect from different lattice point. They may not be in phase when they reach the detector. Okay, you can see the rays A1, B1, C1 is traveling less path. The ray A2, B2, C2 is traveling more path. How much is the extra path traveled by other ray? दूसरी रे ने कितना path extra travel किया है? This separation is, this is the interplanetary spacing of D. Let us say these are 100 plane. यदि ये 100 planes है, then this is the interplanetary spacing of 100 plane. Okay. So with respect to 100 plane, how much is the extra distance traveled by other ray? So let me draw one perpendicular from B1 in
2D,
this direction. One perpendicular plane on this side. This is point P1, this is point P2. So how much is the extra path? P1, B2, P2, right? How much is that equal to? So what is this angle? ये angle कितना होगा? This is, I think, if this is theta, then this is also theta. How much is this line? D sine theta. So this total distance is
2D sin theta.
Okay. So when will my detector receive the maximum light? Detector को कब maximum strength मिलेगा? When 2D sin theta is equal to n lambda. Lambda means the wavelength of X-ray. Okay. And when 2D sin theta is equal to some 2n plus minus 1 lambda means old multiple of lambda, we have minimum intensity. So this is what we expect from the detector. When we get constructive X-rays, we get maximum intensity. But we still do not know what is D. हमें D नहीं मालूम है क्या है. Actually, we do not know which plane are they reflecting from. हमें यही नहीं पता है कि किस plane से reflect कर रही है. This is the diagram for 100 plane. We may have 111 plane also, like these planes, and accordingly, our theta, D, everything will change. We will get similar equation for other plane also. So in other words, we always have this equation, DHKL and the corresponding theta is equal to n times lambda. N means the order of spectrum. For the nearest plane, n is small. The waves which are coming from other planes, the n correspondingly increases. Okay. So we have this equation. How do we get meaningful results from this equation? That we will discuss in the next class. एक simple सा equation है, but it has every information that we want to know. इसमें हर वो information है जो हम देखना चाहते हैं. So how do we retrieve information from such a simple formula? That's the thing that we need to learn. वो main चीज जो हमको समझनी है. So we will invest one more lecture for that part in the next class. All right. Let me end this class here. You can leave now.
Sir?